Hey, those of you that don't recognize or weren't here yesterday, we've got Sean Roberts, who did a great talk yesterday on what Walmart is doing. Randy Bias, who, if there was ever a cloud luminary, he is it. He practically defined cloud. And we've got Mike Yang from Quanta, who's going to provide a pretty good diverse set of sort of vendors, builders, users. So it should be good. So the topic is really talking about hardware, software, OpenStack, and how they all relate. So maybe, actually, Sean, let me start with you. You're a big vendor that, as I understand, has a percentage of your deployments on OpenStack. So what exactly are you doing? What's your design philosophy? How do you think about the world?
You mean as far similar to the commodity hardware? Is that what you mean, or?
Well, in terms of hardware, software, what do you think of when you plan out data centers? What's Walmart doing? Like, is it go to the traditional vendors and buy lots of equipment, or is it, leverage the public cloud, or is it leverage private OpenStack deployments?
Percentage. So
a philosophy. It doesn't need to be exact numbers and dollars spent, although that would be nice.
I actually can't talk right now exactly what we're doing because I've only been at Walmart for a couple months, so I haven't gotten approval to talk about that. But I can talk about.
So for a company like Walmart, that is.
So let me talk about it in the generic. So yeah, I'm dancing around this. So
imagine there was a large retailer.
Yeah. So talking generically, so. Enterprise companies typically build tier 3 or tier 4 data centers. It's got a lot of redundancy. It's very expensive. It's tens of millions of dollars, or sometimes even hundreds of millions of dollars to build out each megawatt. And I can talk more on my experience with Yahoo. So, the ideal way that we want to get towards is to build out tier 1, maybe tier 2 data centers where you get down to maybe $6 or $7 million a megawatt. That there's no redundancies in those kind of buildings. So at Yahoo, we build data centers that were basically just there's a barn with a heat pipe on top and roll-up doors and with an evaporative cooled system. So which really only got used maybe a month out of the year. So generally, if it got a little bit too hot, we just open the doors. So, but obviously that makes the gear run a little bit hotter, somewhere in the 80s to 90s, and it lasts a lot less. So that's, in my opinion, that's the best way to do it. But you need to build your applications and build your software-defined infrastructure to accommodate tier 1, tier 2. If your applications are very resilient and they're not fragile, then you can do that. So large retailer data center strategy might be more like Walmart products than Neiman Marcus pricing, say, as it were. So it's just build commodity infrastructure, keep costs low, keep data center, build costs low, and create resilience at the software layer. Yeah, I mean, essentially the idea is that you build out your applications to be very using distributed systems concepts. So
Chaos Monkey, Chaos Gorilla.
Well, so you can accommodate those kinds of things. So you can have mass failures. You can have a whole data center go down and nobody notices. Maybe it gets a little bit slower, but that's it. So that's
more of a retailer philosophy than an airline philosophy.
Well.
Okay, we got it.
It's hard to make people redundant so far.
So Randy, you've been doing this for years, building some of the largest, if not the largest, infrastructures on the planet for things like large telcos, et cetera. What insights have you learned and what trends do you see as far as both hardware architecture and software architecture and how they relate?
Yeah, so when I started my business cloud scaling, which EMC acquired, we were one of the first 25 companies to support OpenStack. And even before OpenStack, we were doing cloud deployments with CloudStack. And my philosophy at the time was like, we're going to take all the lessons learned from the web scale guys, especially using commodity hardware, and bring that to the enterprise. And we were trying to bake that in first as a professional services business, and then as a product business. So I tried to figure out what was going on with those guys. I got my insight into Amazon and Google, and I found out they used Quanta a lot. And so we started the process of figuring out what does it take for an enterprise to consume sort of, gear directly from the contract manufacturers and ODMs without sort of a third party in the way. The theory being that they could get greater economies of scale, get lower, hardware that was sold at a lower margin, save a lot of money, and so on. And we learned some hard lessons. So one of the first lessons that we learned is that an x86 server is not an x86 server, is not an x86 server. When you get an appliance from somebody like EMC, the same version of appliance is always the same. The firmware is the same. The firmware on the disk drive is the same. The whole thing's validated together as an integrated unit. When you go to Quanta, and this is no ding on Quanta, they're fantastic for what they do, but they don't build integrated, validated systems, or at least that's not their bread and butter. And so, you wind up taking on as a business, like having a certain amount of hardware validation and building tooling around getting that gear on the floor, getting it configured and making it standardized and homogeneous. And somebody like, Google and Amazon can afford to have hundreds of hardware engineers, but the average enterprise really doesn't understand they're in for that. Then the second thing we learned when we tried to move out of sort of x86 hardware and software is we started moving to switches, and we really ran into a lot of problems there because you sort of had, the gold standard of Cisco, and then you had kind of up-and-comers like Arista, and then you had, folks like Quanta and Delta Electronics who were selling, essentially white box switches, but the software on the white box switches, again, no ding on Quanta, was not, really that high quality. And it's that Quanta's focus is on delivering, a large number of high quality x86 and switches. They're not a software business. That's not their fundamental core business model. And so now that you've seen things like Cumulus Linux arise and the Microsoft project to provide switch software, that problem's starting to go away. But I guess the bottom line is that the open hardware or commodity hardware is not free. It takes time and effort and energy and skills and tools, all of which has been, everybody's been leveling up on over the last 5 years. And I think we'll get to a point where it's actually easy to deploy open hardware, but it's not quite there yet.
So just to go back, we've been on stage many times together.
Yes.
And I remember a debate we had about cloud unit costs versus enterprise unit costs probably 5 or 6 years ago, and I remember what you said, which is I was sort of arguing for why the cost structure should be higher if you looked at the whole stack of a cloud provider, simply because the alleged economies of scale and volume purchasing didn't necessarily outweigh some of the other structural elements that went into the price, like margin, SG&A. And you said something that I thought was very, very important at the time, which was that you had to look at the way that enterprise built things. So it wasn't, Sean, your approach that you just mentioned. It was gold plating. So rather than me sort of reiterate your answer, you want to just elaborate, because that was a great answer as to that it was a cultural phenomenon, not so much a technical or cost phenomenon.
Right. This goes to my general argument about what is cloud, and I won't, it's in lots of presentations you can find online. But the general thing is that when you go and you build like the real cloud guys, Google and Amazon and Facebook, they don't gold plate the hardware. They don't have redundancy everywhere. Google's model is to use one top of rack switch. When we went into AT&T in the early days, I designed them a cloud model where we had a single top of rack switch, and they flipped out. They were like, we're the networking company. All elements of the network have to be redundant. And I was like, it's a PCB board with like 3 ASICs on it. I mean, what's going to go wrong? And I talked to Arista and I said, what's the failure rate on these things? Well, we're telling customers it's 0.4% a year, but we've actually in the last 9 months had 0 returns, right? You've got a 99.5, infrastructure already. We're just using a single top of rack switch. We wound up putting in dual top of rack switches in order to gold plate the infrastructure and make it more redundant, and all the challenges around LACP on Linux and all of those things of making the software work, and the fact that MLAG was like different on Arista from Cisco and Juniper and so on. It made it a complete disaster, and reliability actually went down by adding a second top of rack switch, right? These are not the days where you have like a 3-COM NIC that's got like 25 jumpers on it, right? You look at a NIC today and it's just a fat ASIC, right? It either works or it doesn't work. And so I think it's just a philosophical problem, right? The cloud guys just figure things are going to fail, and they build software that routes around the problems, and if a rack fails, it's fine. It's not a big problem. The enterprise has a hard time swallowing that model because the pets and versus cattle thing, which I won't lay any claims to at the moment.
Okay. So, Mike, as far as what you're seeing on the vendor side in terms of customer trends and also the kinds of architectures that you're building, are they more integrated? Is the software integrated with the hardware in your designs? Care to comment on that?
Okay, I think back to Randy just mentioned that, open hardware, sometimes I think it's still not enough. I think he's exactly right. I think a couple of years ago when we worked with him, when he was in other company, I think at that time, I think that's exactly the situation. But I think in the past several years, we've been not only just investing in the hardware technologies, but also, for example, like even we work with Marentus for their unlock program. So it means how the open hardware accommodate to the, with the OpenStack software stack. So we've been thinking of that, and we are doing that, and we have actually packed with software engineers to work with Marentus, and not only just that, but also like a Red Hat and Canonical. We've been talking to a lot of even with the software-defined infrastructures, that type of company. So again, I admit that open hardware is not enough, but once we invested in a higher, level up our position and work with the software partners, especially the software-defined data centers, everything. So I do believe we're catching up, because again, I think the final goal definitely will have enterprise customers to have a best open hardware to cope with the open source, like OpenStack or cloud-native software.
Do you mostly sell to enterprises, mostly sell to cloud service providers, a balance?
Okay, at this moment, I think I should say that, we sell to the big cloud hyperscale data centers with only just hardware only. But the knowledge of knowing the combination, not only just hardware but software, it helps us a lot, because when we define the project with them, we know how to meet their requirement. And most of the time, because we do the design and we know the workloads, so we can provide even much better solution to them, even out of their imagination, So, but for enterprises, we're trying to learn so many things, because the final goal still, once the enterprise customers using open hardware and OpenStack, then it's done. And so that's what you just mentioned, that pre-integrated, and even the full rack configuration, that's what we're doing now.
So, Sean, hypothetically, if you were to pick an industry vertical completely at random that I won't pre-specify, and you were thinking about sort of this balance, Mike comes in to talk to you, maybe with Randy as an advisor / intermediary, and don't you have a trade-off that's kind of, I want to do it myself, but I also want to have a single throat to choke? So how do you figure out that balance of both control and also performance? So Dropbox was mentioned earlier. I think the figure is something like a 3-to-1 cost savings by going to Discotech, which was their proprietary technology, moving out of the public cloud, being able to actually engineer a highly performant infrastructure that met their specific needs, which granted are a little bit unique. How do you balance the trade-offs between grab something that's fully integrated, fully tested, fully supported, versus you get something that you can play with and tune maybe to your specific needs?
Okay, so my experience is probably a little bit different than a lot of other people. I've worked as a consultant for a number of years, and also working at places like Yahoo and others. There really wasn't any generic workloads we ended up running our gear on, and there was always lots of very specific workloads that we needed to run. So almost invariably, if something had been super tested, we'd come up with a use case that would break it in some way. So we ended up, in majority of my experiences of working with generic and specialized hardware, we ended up having to have some layer of, not so much QA, although that's always important, especially if you're going with hardware that's from a vendor like Quanta. They make great hardware, but there's going to be a slightly higher failure rate just because of that's not what they do. They mass produce stuff. So, it's always important to have
Sounds like a potential legal action.
But
I think, why is
always
it a higher
lean on-
failure rate? You think it would be a lower failure rate if they're more standardized, maybe less performant, but you think they'd have mass production fully
well,
figured out?
It's actually been the opposite.
Really?
In my experience. So,
And this to me is interesting. So why, is there some kind of root cause analysis that you would say that is the driver for why mass production would reduce reliability?
well, no, I don't think that's the case. It's just I don't want to speak for you, but there's always been these vendors that these companies that build gear, and then other vendors resell it, and they have a certain amount of QA, and they filter out failure rates that usually we wouldn't see if we're buying it
There's
from one
two
of those.
separate filters, two separate stages traditionally.
Right.
The manufacturer and then the vendor who's packaging up the system.
Right. So if you're buying straight from them, you have to do that yourself, much to Randy's point. So, but my experience has been, even for if I buy gear from a very well-known vendor that's really done a lot of curation and QA of that gear before I get it, I'm usually using it for something they didn't expect. I'm not doing it for just like file sharing. I'm doing something more complicated. So invariably, I have to have something like a performance engineering team, a team that understands hardware and firmware and can do some level of diagnosis of how this stuff works and when it does fail. So does that answer your question?
Yeah, I think so. So, Mike, to go back to you, there's sort of then this set of trade-offs between performance, reliability, commodity, hardware, level of integration. What's your philosophy as to where the sweet spot is on that?
Okay. First thing, I think I would like to express the actually, as Randy just mentioned, that from the hardware design and the manufacturing, basically the quality level should be high, because it's just many important ICs. The rest of others, I think you just put everything together. But of course, from the design point of view, we still have a special, recipes, means that we have to do our, disciplines. But, from just Sean mentioned that the open hardware is definitely not enough. So I think if, the audience or, gentlemen, that if you are, you are welcome to come over to our solution centers, because over there, we demonstrate all the hardware we have and all the, for example, like OpenStack solutions with different workloads. We welcome customers like, companies like big retail, something, you can just come over to our solution centers, and with your workload, we can pre-qualify it and do all the POCs by means of your applications. So this is something that we're trying, we're trying to help customers, especially enterprises, to help them to easy and fast deploy.
Yeah, I wanna try to help people understand kind of the Quanta model, because like we're talking about quality, but like Quanta, you probably don't know this, and maybe Mike's not allowed to say it, but they manufacture Apple laptops. I mean, you don't get much higher quality than an Apple laptop, right? So the quality challenges, I think, have less to do with how Quanta does business, and they have a lot more to do with like the fact that the x86 systems and the switches are they're like 30, 40-year-old technologies. I mean, you have like BIOS, and Mike doesn't build his own BIOS, he gets it from somebody else. They start revving the BIOS that comes on the chips that he gets, and then you sort of have all this variability in the x86 supply chain, so that like over a period of time, say a year and a half, with the same Intel processors, you've got multiple revisions of the Intel processors, of the firmware and all the components in the box. And to a certain degree, it's not Quanta's job as a mass manufacturer to like make sure that you get the same Haswell box every time. That's the job of your enterprise vendor. So Quanta's trying to level up and learn how to do more of that, and the vendors are trying to learn how to sort of like solutionize, going up the stack. So I hopefully that helps clarify that a little bit.
Okay, so complex set of trade-offs, interoperability, complexity,
Yes.
a lot to think about. Go with good vendors, no matter what segment you may be in, retail, and take it from there. So thank you guys very much. Please give our panelists a big hand.
Thank you. Thank you.